Hello guys, welcome. In today's video we will learn about concept of data structures and algorithms, that is recursive algorithm. It's a very famous algorithm. What does word recursive means? Recursive means repetitive. So if a algorithm is repetitively called, it is called recursive. So we will go into the definition now. So recursive algorithm is an algorithm that calls itself for the to solve the smaller instances of the same problem until the base case is reached. So when the base case, the last case of the problem is reached, this algorithm will be called again and again. So when the last case is reached, which is we call the base case, it is relatively very simple to solve this problem directly by applying simple operations. So this is the meaning and definition of recursive algorithm. So first of all, to understand recursive algorithm, we will see few examples, famous examples of mathematics regarding recursive algorithm, and after that we will solve one problem statement to understand it better. Ahead I will be bringing more videos on recursive algorithm problem statements, but in today's starting session we will look at few examples and one problem statement itself. In this video, this much is enough. So my battery is very low, that's why I am checking, because without battery it gets dead. So here, first of all, what is the first example we will look? It is the factorial example, which is very famous, which works on recursive algorithm. What does factorial do? If you have seen in maths, factorial means, if I say 6 factorial, that means I want to add multiply from the 6 till the end, till the 1. So this is the factorial, means multiplication from 6 backward till 1. So this is the factorial. So if I write 5 factorial, this is the symbolization of 5 factorial, 5 exclamation. So when I write 5 into 4 into 3 into 2 into 1, this is 5 factorial. So what I will do, definition, I will create a function. First of all, we will solve the problem by creating functions, because recursive algorithm, I said, is it will create a function and then it will be called its smaller instances until it reaches the base case. So I will call write a function factorial, def factorial. It is a function. Factorial spelling is wrong. Factorial. So I am saying a factorial, like 5 factorial, I will take it as n. So 5 factorial n. So what is the base case? 1 is the base case. Anna, if 0 is reached, that means entire multiplication will become 0. That means there is no use of it. So what we will define the first condition or the base condition as, if n is equal to 0, then return 1. This is the base case. Done. Else, what we want, else return what we want. Factorial 5 is 5 into 4, means 5 is n. Okay, and 4 next value is 4, because it will call the smaller instances, as the definition says. So smaller instance is what? 4. So how we will get, if n is our current value, how will we get 4? By reducing it by 1, n minus 1. So what will be our return value? Return n into smaller instance, factorial n minus 1. So this is our function is ready. So I will run it. Okay, now we will call this function factorial 5. Check with calculator also the value, factorial 5 I will call it. It's working. 120 is the answer. Now we will move to the next famous example of mathematics, that is Fibonacci series. Fibonacci is also used in stock trading also. And many places in the nature Fibonacci series is used. Some leaves also follow the pattern of Fibonacci. So what is the Fibonacci series of mathematics says? It is the series which is formed by addition of previous two numbers. Okay, so Fibonacci. So we will create a function def Fibonacci. We'll enter the value n. So what is the base case over here? If the values goes below 1, then entire thing will make no sense. So we will create a f n is less than equal to 1. This is the base case. Return n. Else अगर नहीं है, what we will do, return Fibonacci n minus 1 into Fibonacci into not. I said previous two numbers should be added for the next number. So Fibonacci n minus 1 is the previous number and previous second number will be n minus 2. So this is done. Now I will call this function Fibonacci. I will say 8. So here is the answer, 21. Now we will solve a problem statement using a recursive algorithm. So what is the problem here? Find the maximum element. We have to find the maximum element from a sequence of any element. Means there is a sequence. Sequence can be anything. So we will here consider a list. A tuple can also be considered. Sequence, an array can be considered. So we will take a sequence of n elements, and from that we have to calculate a maximum element. You know, this problem can be solved with another approach, that is iterative approach. If we will do iteration, then also this can be solved. And we have to decide while programming, we have to consider that sometimes iterative approach is better than recursive approach. When the problem is complex, we will not go for recursive approach, we will go for iterative approach. So I will show this problem statement with two methods, first with iterative and then I will show it with recursive algorithm. So remember always, if the problem becomes complex, don't use recursive, go for iterative methods. Okay, so above we have solved this recursive algorithm in examples with the help of functions. Now I will show you same recursive algorithm with class approach also. So this will cover both the end of our Python, that is functional approach, and second one is the class approach, class and object approach. So first of all we will create a class. We have to find the maximum element, so I will call it max element finder class. Okay, so first of all what we need, we have to find the maximum element from what? Sequence of n elements we have to find. So what will be our initialization when class will be called? A sequence. So I will define an init function, which is we call Dunderite or magic function. So init self and sequence for seq. So I will call it as self dot seq is equal to seq. This is done. Now I said that I will solve it by iterative approach first. So we'll write find element, max element. We will write max element. It should be very clear. Functional names, from function name itself what we are doing. So I will write, let me check, battery is going okay. So find max element through what? Iterative approach. That's why I have written like this. So here I will call self. We have already declared our sequence of n elements. So what I will do here, first of all, I will initialize one element, max element, because we have to find the max element. So where we have to find in sequence, so first of all I will give it sequence of 0. First number of the sequence is the max element. Now I will use the iterative approach for element, any other numbers in the in which self. So here I have to mention self everywhere because I am not using it. Self dot sequence, okay, for element in what we can say sequence. First of all, we have given the first element to the max element, so remaining will go here because we want to iterate on the remaining element. So I will write 1 to all the elements left of the sequence should come in the iterative. So what I will do, max element is equal to what we can say element. No, we have not mentioned the condition. First of all, it will take the element from the sequence. Now what we have to check, we have to find the maximum element. How we can find the maximum element? We will use if condition. If what I will say, if element is greater than max element, if element is greater than max element, then change the max element is equal to element. Okay, and then if condition is satisfied, then return max element. Okay, so this is done iterative method. So next we will see it through the recursive method. Find max element through what? Recursive. So I will write recursive and I will pass again self. Let's check out if it went wrong or not. But in recursive method we cannot go directly because we have to know our elements also, how we will perform the operations. So for that I will write self, and one I will define start element, that is start is equal to 0 and end is equal to none. Okay, I have defined it. Now if I will say I will define a condition. If end is none, means if end is none, that means no element is there in the end. First we have to define the element for it. So I will write end is equal to length of self dot sequence and -1. So this will define our what we can say none end value. Now what there can be a condition in recursive function also. Somebody witty person, a clever person, what he will do, try to do with recursive function, okay, I will put a 0. Now I will check whether this function works or not. So for such kind of crooked person, we will define our base condition first. So if somebody enters, so what I will write, if start is greater than equal to end, when end is none also, or -1 as we defined, so return. what we will return? Return self self dot sequence start. Here also we will define the condition, like if start is equal to length of self dot sequence, then only return self dot sequence dot start, or else put none. Okay, though both the conditions are now satisfied. Now we will create our recursive algorithm over here. So what I said, recursive algorithm call itself for smaller instances. Suppose a 10 number series is given. Okay, 1 2 3 4 5 6 7 8 9 10. So it will call smaller instances until the base case is reached. So here what we will do, we will divide the entire sequence into a series. For that, what I will mention, mid equal to start plus end, floor division by 2. So it will divide into the mid half. So first we will go to the left half, max left half half. So what I will do, self dot find max recursive, and I will mention start comma mid. Half the way it will solve from the left hand till midpoint. Now I will call right hand side max right half, and I will say self dot find recursive. So here I will mention mid plus 1, and I will say till where end. Both the halves are solved. Now what I will do, from this base case can be reached, so I will return the two numbers. Out of two numbers I will select one, so I will say max max left half comma max right half. This will be returned. So this is formed now. Okay, this class is complete. I will run it. We will check whether it is correct or not. Syntax error, where it is. Okay, if start is equal to this is the error. So if start is equal to length, now the class is correct. So we will initialize the class with result. Now first we have to define a sequence. Sequence is equal to, I will mention a list 6 comma 3 comma 2 comma 7 comma 9 comma 8 comma 5. This is my sequence. Now what I will do, result, I will call the class max element finder, and I will pass this sequence over here. And what I will do, first of all I will call our function using result dot find max iterative and result dot find max recursive. Both the functions are called now. So let's just check whether our program for the problem statement is correct or not. It's wrong. Not supported. Where? Okay, mid plus 1. So what's the problem? I have made mistake. Start so here it is, start till mid and mid plus 1, everything is right here. Start plus end, okay, that's right. And okay, where I made a mistake, it is showing here find max element recursive start till mid. Start plus end, is not supported between instance of none type and none type. Okay, start equal to 0, end equal to 0, none. Okay, I have also defined if end is none, end is equal to length of self into sequence minus 1. Okay, this is also right. Now if start is greater than equal to, if start is greater than equal to end, that is also right. Return self dot sequence start if start is equal to length of sequence, else none. So where the mistake has been done? Self dot find max element recursive find mid plus 1 and max left half, max right half. Okay, everything is right here. Start to mid, where it is wrong, man. Okay, if I found the error. If it is equal to, that means it is wrong. It should be less than, then only. Okay. This was the mistake. So we will rerun it. And now I will do this. 9 is the output. As we can see, if I called it result, we will call it find max recursive again, and we will see the result. Okay, 9. So it is correct. Separately also we have called it, and we'll again call it result find max iterative, and we'll check whether it is correct or not. Both are correct. So this is the class method, and above I have shown you with the functional method. Thank you guys. In the next video we will few more problems of recursive algorithm, and in coming videos I am going to cover computer vision and generative AI also. Thank you.